All right, here we go. Series circuits now. So again, we're going to use that I equals delta V over R. We're also going to use RS, which is our which is our series. All right, is equal to R1 plus R2 plus R3, so on and so forth. Okay, so here now we see the resistance of A, that's 255 ohms. All right, the resistance of B is 292 ohms. Oops, man, that's bad. Oh, God, that's real bad. Sorry. All right, then we got the voltage of A is 17.0 volts. All right, no other information is available. All right, we want the current of the circuit. Remember now, because this has one route, that means that the I total will equal the I through A, the current through A, and the current through B. All right, so to find the total circuit, well, if we know the voltage at A and we know the resistance at A, we can find our current as it runs through there. All right, so I will equal the 17 volts divided by the 255 ohms. So 17 divided by 255. This current here is going to get measured at 0.067 amps. All right, so the current will be 0.067 amps. All right. What is the battery voltage? Well, if I know the voltage of A, if I add that to the voltage of B, that'll give me my voltage total. Well, good thing is I just found the current. So if I know the current that runs through here, so the current of B is 0.067 amps, right? So I can find my voltage. So 0.067 amps, that's the total current running through there, equals delta V over 292 ohms. All right, so multiply 0.067 by that, we get a delta V here of 19.5 volts. Well, in order to find the total, because that's going to be V at B, I'm going to add that to 17.0 volts, which is VA, all right, and that'll give me my total. So 36.5 volts is my total for that one, for the whole entire battery. Okay. All right. A series circuit is made up of a 12-volt battery and 3 resistors. The voltage across one is that. The voltage across another is that. What's the voltage across the third? All right. Well, our total voltage here is going to be V1 plus V2 plus V3. And it's just all of those added up together. So if this is 12.0, the first one is 1.21 plus 3.33 plus V3. Okay, 1.21 plus 3.33. I'm going to subtract from both sides 4.45. 4. All right. So in this case, V3, 12 minus that answer, should be 7.46 volts. All right. A 22 ohm resistor and 33 ohm resistor are connected in series and placed across 120 volt potential difference. So if you look at this, right? Oh man, let me redraw that. That's bad. Sorry. So boom, boom. So I've got one there, one there. All right, this is 120 volts. This is 22 ohms. This is 33 ohms. All right, and that's coming from right there. Okay, the equivalence resistance. Well, equivalence resistance basically means the total resistance. So RS equals, well, I've got resistor 1 and resistor 2. So 33 plus 22. All right, so my total resistance here is going to be 55 ohms. All right, what is the current in the circuit? Well, if I know the total resistance, right, and I know the total voltage, I equals, that's going to be my total voltage is 120 divided by 55. All right, so 120 divided by 55. My current here is going to be 2.18 amps. All right, that's going to be my total across there. All right, across each resistor. All right, so if I go across each resistor here, that means that that current, so this is at I2, it's going to be 2.18. At I1, it's going to be 2.18. All right, to find the voltage across those two, delta V, whoops, sorry, let me write that the better way. All right, so 2.18 equals delta V over 22. Multiply those two together. Delta V is 2.18 times 22. So the voltage at the 22 ohm one is going to be 47.96 volts. All right, so 47.96 volts. I'll do the same thing over here. 2.18 equals delta V over 33. So 2.18 times 33. The voltage at the 33 ohm is going to be 71.94 volts. All right. The equivalence resistance of this one, all right, we got some kilos in here, huh? So our total resistance is going to be 3,300 ohms plus 4,700 ohms plus 3,900 ohms. All right, so 3,300 plus 4,700 plus 3,900. All right, that's going to be 11,900 ohms is equal to our series or our total, whichever way you want to look at it. All right, what is the current there? All right, so we know it's a 12-volt battery. To find the current, I will equal 12 volts divided by 11,900 ohms. I equals, so 12 divided by that, 0.00101 amps. All right, because of the series, that's going to be each one of them. All right, what is the voltage drop across each resistor? Ugh. All right, so that's going to be 0.00101 equals delta V over, and then we just pick our resistors. So that'll be 3,300 ohms. All right, so times 3,300. So the voltage of the 3,300, sorry, that was bad, of the 3,300 ohm resistor is going to be 3.33 volts. All right, we're going to do the exact same thing. The only thing I'm going to sub out here is this will be 4,700 ohms. So 0.00101 times 4,700. So the 4,700 one will be 4.75 volts. And then I'm just going to take the last one in there as 3,900 ohms. So 3,900 ohms, that will be, the 3,900 will equal 3.94 volts. And I got to give more space there next time. All right, so if this reads 0.20 amps, all right, the nice thing is that there's only one route. So because there's one route, that means the current doesn't change. So 0.20 amps, 0.20 amps. So 0.20 amps, 0.20 amps. That current is going to stay exactly the same. All right, 58 here. We want the equivalence resistance. That's the total resistance. So we're going to take 6,800 ohms. Add that to 1,100 ohms. Oh my goodness. Boy, oh boy, those are bad. Those are bad. Sorry, folks. Plus 10,000 ohms. All right. Our total there 680 plus 1100 plus 10,000. This will be 11,780 ohms. All right, last thing. All right, so if we got 10 volts, 35 and 15 ohms, we want to know what should the ammeter read. Okay, so our total resistance is going to be 35 plus 25. The whole series together is going to be a 50 ohm resistor. All right, so to find the ammeter, that's going to be equal, I is going to equal 10 over 50. All right, so that's going to be 0.20 amps. All right, well, now if we want to find voltmeter 1, we know that the current here is going to be 0.20. The current there is going to be 0.20. All right, so we're going to take 0.20. That's going to equal delta V over 35. Multiply those two together. Delta V here, 35 times 0.2, should be 7 volts. All right, now, two different ways you can do the second one. So if our total is 10, that's going to equal V1 plus V2. So that'd be 7 plus V2. V2 there would equal 3 volts. Oops, minus 7, minus 7. Right? The other way we can do it is take 0.20. That's going to equal delta V over 15. All right, multiply the two together. Delta V, 15 times 0.2. That is going to be 3 volts. So either way you like to run it, that's how you can run it.